Hello and welcome to today's 25th webinar in the On the Move webinar series and our final installment in 2018, Make Robotics a Reality in Your DC, brought to you by Honeywell Intelligrated. I'm Tracy Niehaus, Director of Marketing for Honeywell Intelligrated, and I'll be your moderator today. We have just a few announcements before we begin. Please note that this presentation's audio is provided by phone number or through your computer sound system, so be sure to turn up your computer's volume. You may ask an online question at any time throughout today's presentation in the Q&A feature along the right hand of your screen. Simply type your question into the text area and hit send, and please keep the send to default set as all panelists. Questions will be addressed at the conclusion of the presentation with the exception of technical questions that can be asked and will be answered real time. And please note that we recommend that you be hardwired when attending this webinar, as a Wi-Fi connection may result in lag time in slides updating or graphics loading. Today's webinar includes polling questions. Please feel free to answer these questions when they appear, and be sure to click submit so we can include your response, as we will be sharing the results real time during this live event. If you'd like to revisit key sections of today's webinar, it will be available on demand at intelligrated.com/on-the-move approximately 48 hours after this live event. And you will also receive an email in a couple of days with a link to the recorded event. Now on to the presentation, Make Robotics a Reality in Your DC. Discussing today's topic will be Matt Wicks, our VP of Product Development for Honeywell Intelligrated. Matt has more than 23 years of experience in the material handling industry, with expertise in the areas of controls and software integration for high-volume manufacturing and distribution systems. He also has extensive experience in the field of advanced robotic solution development, including robotic solution integration. He holds a bachelor's degree in electrical engineering from the University of Missouri-Rolla, and currently serves as second vice chair on the Robotics Industries Association Board of Directors. Matt is also a registered professional engineer in the state of Missouri. And with that introduction, the webinar will now begin.
Well, thank you, Tracy. Well, I appreciate everyone joining me today and talking about robotics, the end of the year, and hopefully everyone's out there doing their Christmas shopping and keeping our industry alive and well. So I want to start out with a little bit of work for each other, everyone. Want to get a feel for the audience. So I've got our first polling question is up here. What industry do you come from? Are you in retail and e-commerce? Are you doing operations and maintenance in that industry? Are you in general warehousing and distribution? Do you work for a 3PL? Or are you a robotic integrator? Or do you actually manufacture robots? Are you a part of a robot startup? So I'd like to get some feedback on what the audience is here, and then we can gauge the presentation based upon what audience that we've got. So while that poll is being collected, I am going to cover a little bit about what I'm going to talk about today. So today we're going to talk about, some of the challenges that we have in the warehousing and distribution space is the scarcity of labor, and a lot of pressure that's been put on to the distribution operations. And so a lot of these challenges are because of the explosive growth in e-commerce and order fulfillment. So the warehousing and distribution operations and order fulfillment is a very dynamic and chaotic and very unstructured environment. And historically, it's not been great for robots. But that's changing, and that's really not true anymore. It's not a good environment for robots. There's been advances in key technology, new technologies in sensing, AI, computer vision, that are really enablers to these robotic solutions. We're going to talk about those today on this webinar. So the poll results are in here. So we've got about 35% in the general warehousing and retail space, 22% are in the e-commerce. So yeah, we've got a fair amount of folks that have got some experience here and some of the challenges that I'm going to talk about today. So some of this probably won't come as a surprise to you all. So what I want to do is talk about the challenges here in the environment. So I'm going to walk you through a typical supply chain step-by-step of the things that happen in e-commerce and order fulfillment. So I'm going to do a walkthrough from the time a part or an object arrives into the States here, and walk you through all the way through the time that an individual gets this. What I want you to focus in on here is count the number of times that the items are handled or touched through this process. It's actually a surprising number when you start to walk through each one of the asks throughout the supply chain. So when we start out, we start out as the container arrives from overseas, comes into an import distribution center. The containers are full of your products. They're unloaded, generally speaking, by hand. They're sorted and scanned on the dock side. Sometimes they're palletized. And then they're put away into totes. And those totes are then stored and we're ready for fulfillment. There could be actually a whole other process here where some retailers will actually have a secondary process that just handles their imports. And so actually, this is a pretty conservative look on things. So once it's stacked in the shelves, it's all ready for online storage, or it's all ready for online purchasing. So we've got our happy couple here that places their order online. They decide, hey, we're going to have a baby, and we're going to buy a book on baby names and a plush toy. So typically speaking, e-commerce order size is around 2. So that's the example we'll use today. So once that order is placed, then the employee then will pick items, will be issued a command typically from a WCS or WES. The items will be picked by batch. So we'll do multiple different orders that are picked by those individuals walking around in carts off of shelves. Those items then will be delivered to an area where then they sorted out by the actual orders that those individuals purchased. So we're up to 8 touches already, which is, again, this is only a part of the process. So once those items are then sorted, we place the items into the boxes. They're packed out. They're placed on the conveyor, and then the conveyor then sorts them out to the parcel trucks and on its way to the customer. So there's 12 touches there, but that's not it. So once it leaves the retailer, now we go out to the parcel distribution. So now those trucks arrive at the parcel distribution, and then they're manually unloaded again. Now, these larger facilities will typically have a conveyance and sortation system that will sort out those products and ship them down to areas for secondary sorts. That secondary sort is typically manual. So we'll do a secondary sort down to the final haul line truck, and then that's delivered into the truck and then manually loaded into the truck. But we're not done. So that's up to 15 touches. So that line haul truck then goes to the local facility. So again, like I talked about before, sometimes the product will come into a local facility, go into a main hub, and then back to a local facility. But for this example, I've shortened it. And again, now the products are manually unloaded. They're done a manual pre-sort, manual secondary sort, sorted down to the route van and out to the route van, and then delivered to your home. So that's 21 times that the product is handled in this scenario very manually. And so it kind of gives you a little bit better appreciation for the process from the time it arrives from overseas until the time it arrives at your door. There's a substantial amount of handling of those products. And so why is it important to have this discussion now? Well, but how does it relate to robotics? Well, the challenge really is the labor that is available to do all those touches is dwindling in. There's a substantial amount of challenge with fulfilling those jobs. The growth of this industry, whether it's parcel handling and e-commerce, is outpacing the availability of labor by a 6-to-1 margin. And that's on top of this year-over-year growth of 25% in e-commerce distribution. That's a substantial amount of acceleration in our customers' businesses. And so we see all this with this. So now in that example, those are a very manual process. So that's actually fairly typical of a distribution center operation. There's a substantial amount of manual labor that's done inside of a DC. That's not to say that the labor in any particular facility is 80%. So some facilities are highly automated. Some facilities actually have no automation at all. So when we talk about the labor that we have and the challenges with labor, the jobs that we just highlighted there are not the best jobs in the world. They're dull, they're dirty, they're dangerous jobs, and there is a substantial amount of turnover for warehouse workers, up to 30%, 36% turnover rate in warehouse workers. That translates into additional costs for the end customers here. The costs to rehire individuals range from 25 to 150% of the employee's annual salary. Substantial costs in just replacement of that labor. The workforce is getting older. 30% of the workforce is age 55 or older. It's a very physically demanding jobs as well. Again, that contributes to that turnover rate. So the statistic for 2017 is 600,000 jobs were unfulfilled in the warehouse. And that translates into loss of productivity and delays in orders of shipment. So this is a real problem that companies are having and facing right now, and they're looking for robotics to help augment that labor workforce. Another key factor here within the labor market is the jobs. Like I said, they're dull, they're dirty, they're dangerous. Repetitive motion injuries are a substantial cost, $80 million annually to employers. That's a real thing. I just recently had a conversation with a customer a couple of weeks ago, and this was the #1 thing that was driving the automation solution. It wasn't the labor availability. It wasn't increased productivity. It wasn't any of those things. It was the fact that the labor that they were using for certain jobs were so injury prone that they needed to look at automation to get those individuals out of those areas. Very telling. So, second poll question. What's your top consideration when evaluating robots in the warehouse? So I mentioned about labor. I mentioned the labor availability, the injury rates, clearly critical. Productivity gains, when we apply a robot to a solution, can it perform at a higher rate, more reliably, more repeatably, or are there other factors that are driving? I certainly get that all of these things are important and critical, but I'm looking for your feedback on what do you see as the most important thing for robotic solutions to address within the warehouse? So while that polling is coming through, I'm going to go to the next slide and talk a little bit about how robotics are evolving in this space. And I don't mean that they're becoming sentient or anything like that. What I mean by that is robots are evolving to a place where they can actually solve the problems that we have in the warehouse. So on the lower left-hand side here, we have the current state of where, for the most part, where robotics are today. So robots have been out there for quite some time. We've been in the manufacturing space. They've been in an automotive space. They've been doing work in manufacturing for quite a while. And those applications are around things that we have a lot of prior knowledge about. So like when you're manufacturing a car, you know what that car is going to look like. When you're palletizing a product, the palletizing robot knows what that product is going to be handling. And so it's the end of arm tooling and all of the sensing is developed with the sense and understanding that it knows this information. The warehouse is not the case. We've got this very chaotic world here where the products are ever changing. You don't know what you're going to get. It's like a box of chocolates. You never know what you're going to get. And it also changes over time. Even if you think you know what you're going to get, then things like holiday season comes up and your product mix changes, or the volume obviously will go up, or the packaging type changes, or marketing decides they're going to put some new pretty boxes and packaging material around it to increase their sales. And so there's these challenges that really present to the robotic solutions that are new challenges that robots, generally speaking, haven't been able to do before. And so what enables a robot to function in the warehouse is things like these new technologies such as computer vision systems, new sensing technology, improvements in grasping and manipulation, things like mobility, the software and machine learning. These are all enablers, and I'll talk about each one of these later. But they're all allowing the robots to be able to function in these environments, which is more of these partially structured or completely unstructured environments. So to think about this is like a completely structured environment is like, you think of it like a train on the tracks. You know where you're going to go. It's going to go from point A to point B, not a whole lot of variables. That partially structured is, think of it more like driverless vehicles, right? They're on the road. There's some variability here to the roads and the dynamic things that happen out there. But there's still some level of structure to this. And then this completely unstructured is where the cars are off the road. They're, you know, out in the middle of the forest or out there in the middle of the desert. They're driving and it's completely chaotic. And so the problems that we face in the warehouse around that partially structured and completely unstructured environment. So the polling results. So 51% are saying that the labor savings and the labor availability is really what's driving this in the marketplace, followed by a close second, which is the productivity gains. Reducing injury rates comes in at 2%, and nobody said other. Okay, well, I've got some exciting news. We are announcing the robotic solution to address all the challenges that I just covered. It solves all the problems that we're looking for here. And that answer is Rosie the robot. Because Rosie is exactly what we need to do all this. She's got the brain, she's got the mobility, she's got the grasping, she can do it all. Unfortunately, Rosie doesn't exist yet. And so we've got to come down to reality here. So where are we with regards to making our robotic solutions function like Rosie the robot? So let's break this down a little bit. Let's break it down into the things that are enabling robots to be able to function in these environments. So the hands, the manipulation, to be able to take the boxes or take the items and do what you need to do with them. The brains, the computing power, the cloud computing, the eyes, the new sensing solutions, new sensors, doing perception, understanding the environment. And then lastly, the feet, the mobility, being able to move around in the environment. These are all enabling technologies for these solutions. So a little bit of background. So a lot of the robotic solutions today, they're really not new ideas, but they're just viable now because they address these challenges from a speed perspective and a cost perspective. You know, we've been able to put a man on the moon, but it was really costly, but it was some pretty amazing technological achievements. Same with, you know, we could do a lot of this work for a while in the warehouse, but it just hasn't been feasible because the costs are so high or the speed at which these robot solutions function, it just wasn't viable to provide the value to the end customer. And so things like the sensors, the vision technology, the new mechanics, mobility, and computational power, all of those technical improvements are allowing these solutions to be feasible where they weren't feasible today. So first is the vision and sensor technology. So this is a combination of a lot of different ways to allow the robot to understand its environment. So whether that's LiDAR, structured lights, 3D stereo cameras, it's a means for the robot to understand its environment. And not just understand it, but understand the physical makeup in three-dimensional space. Because not only do you have to see what's in your environment, but then you actually have to maneuver and manipulate things within that environment. And so more information is required for these robotic solutions to function. And it's not just the vision too. When we talk about this perception, it's the sensor fusion of things like force feedback, tactile feedback, RGB cam imagery, as well as the LiDAR. also multimodal sensing, things like IR, and pulling those all together to give that robotic solution an understanding of its environment more than it's ever been able to do before. Advanced mechanics. So here's a couple of images of a couple of different grippers. So they're very soft grippers that allow the tools to be much more compliant to handle a wider range of products than we've been able to handle before. So, you know, if you look down at your hands and how pliable they are and how they conform to objects when you pick them up, robotic technology is evolving in that space as well to allow that compliance around objects to be able to handle things that robots traditionally haven't been able to handle before. Other things like also collaborative robotics, like those automotive robots I talked about earlier. They're big, bulky, high-speed, giant arms that are really, they're dangerous. And so they have to be fenced in so that, and the proper safeties are applied around it to allow them to function, but not be, not get into the same space as people are working in. Collaborative robots, on the other hand, are designed to be able to work with people, to collaborate with people, to be able to help them do their jobs better, faster, more efficiently. Not that safety isn't a critical factor here, so the designs of these collaborative robots allow the safety threshold to be lower, so there's still risk assessments, there's still understanding when, what kind of safety needs to be applied, but they are much more geared towards being able to use these in these types of environment around people. And then I mentioned about the advanced grasping and planning, as well as the tactile sensors. Mobility. So this is another one. So we've had AGVs around for quite some time. AGVs use fixed infrastructure to find their way around a facility. So this is dating me a little while, but they used to put wires in floors, and the robots, the AGVs, would follow the wire along. Where that model broke down was that if something happened in front of these AGVs, more or less they would just stop. They couldn't navigate around obstacles. They required a lot of infrastructure, and that tended to be fairly costly. So mobility today is now using a lot of these sensor technologies to pull in information and allow the mobile robots to perceive their environment. And then not only just perceive it, but then plan how it navigates in that environment. So if somebody walks in front of one of these mobile robots, the robot can see that and then say, hey, I need to just get around that individual. So it uses that additional level of cognition to make those decisions. And that's enabling a lot of different applications that I'll talk about a little bit later. And then advances in battery technology, and then I mentioned about the sensor integration. All those types of things are really making robots a lot more mobile than they've been historically. So there's also combining the two, so combining mobility with the mechanics to do new things that we've not been able to do before. So this is still a ways off, so we're not quite there yet, but here's some examples of where mobile robots have been combined with articulated arm robots to provide this additional functionality, not only just to navigate in the environment, but then once you're there, allow that robot to do some level of manipulation, whether it's picking an item, picking a case, or doing some other kinds of task. A lot of this activity is around machine tending in the manufacturing space, simply because a lot of that is a lot more structured than what we have in the warehouse. So not that this isn't, well, this is not quite there yet, but something to keep an eye on as we move forward in time. So probably most of you on the call have seen the Boston Dynamics videos and seen robots doing parkour and some really impressive things mechanically. I thought it was worth a call out here because it is very impressive that some of these robots can walk around and navigate inside of really chaotic environments. And so again, it's not necessarily something that's being deployed in the warehouse today, but something to keep your eye on. So one of the key enablers here is the computational power for these solutions. We've heard a lot about AI, we've heard a lot about machine learning, and this is being propelled by the advancements in computational power. It's allowing these robotic solutions to be able to do inferences on those AI models very quickly. It also allows the robotic solutions to be able to process very complex algorithms for computer vision, motion planning, grasping, very, very quickly. And again, it's to allow these solutions to achieve the ROI that is required to make them viable in the warehouse. There's also a lot of other advantages behind some of the computational power, doing things like predictive analysis for cloud-based computing, some really interesting things that can happen with the advancements in the computational power. So I mentioned about machine learning and AI. So I don't have a video here, but if you get a chance to check out this arm here. So this is where robots are actually becoming learning systems. And again, it's not like the sci-fi kind of crazy, these things are becoming self-aware. But they're doing some very impressive things within the context of very goal-minded tasks. So in this particular one, there was this is an arm or gripper from a company called Shadow. That Shadow hand is just, it is a manipulator very similar to the human hand. And what some researchers have done is taken and trained this machine learning model to allow the hand to manipulate a block to reach a certain goal that's given by the researcher. So on the lower right-hand corner, you see a goal of the N facing forward, the E to the left, and the A on the top. The AI model then learned how to rotate that box inside of the hand to meet that goal. That doesn't mean that the robot knows what a block is or how to stack blocks or that it's made of wood or any other kind of contextual information around it. It's very goal-centric. But what's just impressive is that there's a high degree of freedom within that gripper that really is enabling that solution to be able to achieve that very defined, tangible goal. So cool stuff that's happening there, but we still got a ways to go. Connectivity onto a single platform. So again, there's lots of very impressive things that can happen within the robot system itself. Cloud computing is enabling robots to take that information from a particular robot, maybe a learning at a particular facility, take it up to the cloud, and then push that back down to other robotic platforms. So maybe a new novel product that a particular customer site is presented to one robot, but at some point that's going to be out at all of the other sites. Well, now by leveraging cloud platform, that information then can be passed down to the robots and enabling the new feature, even if these robots have never seen that particular product before. So very powerful things that are happening as it relates to the connectivity of robotic solutions. So let's just talk about market applications. So where are robots applicable? So here's just a broad path of all of the different, of a typical warehouse in a distribution. There's lots of opportunity here to be able to leverage robotic technology, whether it's fluid truck unloading, picking with a mobile robot, mixed load palletizing, each picking, sortation, lots of different opportunities here. Palletizing. So as I mentioned before, palletizing has been out for quite some time. So this is real. This is real and now. So there's opportunities here to be able to apply the palletizing technology in the warehousing space. A lot of it we're seeing here in these examples are case pick, whether they're in the variety of different types of tooling is customized towards those particular types of cases. And so it's not necessarily something that directly lends itself towards all warehousing applications, probably more so in the tote handling arena than anything, but a lot of customers are leveraging the totes that in their operations and seeing ways to be able to further advance their automated solutions with palletizing type of robotics. Depalletizing. So a lot of these distribution centers go through a depalletizing process prior to like a replenishment. So there's a lot of different opportunities to leverage technology for depalletizing. Primarily, there's ways to do a semi-automated approach to maybe make that depalletizing operation a little less difficult on the operators. There's also ways to do full layer handling of single SKU pallets, and then also solutions out there that use either tie guard claws or even some solutions that can do single case pick-off pallets. And again, a lot of these solutions that I'm talking about leverage the tech that we talked about earlier. Robotic loading and unloading. So this is some of the newer technology that's out there. Inside of a trailer, inside of a warehouse, in the middle of summer in Phoenix, Arizona is miserable. It is just not a great job to be out there unloading or loading trucks. And so we're seeing technology move towards being able to solve those problems inside of those trucks, at least as it relates to the unloading. And then as it relates to loading, ways to augment that manual labor with things like telescoping extendables and those kinds of things. But on the unloading side is really where the tech is right now, that these solutions are becoming more and more viable. Each handling and item handling for order fulfillment. So this is where we've got operators that are doing that order picking operation that a robot would be doing, where it finds the objects inside of those totes, be able to isolate those objects, be able to handle those, pick them out of the cases or totes and place them into your order tote, or maybe do batch picking for a secondary process to pack out. And this is a confluence of a couple of these things. So in the examples that I show here, it's using some of the advanced mechanics of the gripper, so these soft compliant grippers, as well as using things like machine vision and some of the machine learning to be able to allow these robots to be able to pick items that it may not have ever seen before. Mobile robotics and order fulfillment. So talked about some of the tech that went into mobile robotics using the SLAM technology. So that technology then is used to allow robots to augment things like the goods demand for replenishment. So delivering cases or items to a replenishment station that people are doing each picking in. The robot handling, so actually getting those each picking robots to pick directly off of these mobile robots and supporting that operation. Other things that the mobile robots have been used for is like full load handling. So these are the bigger units. These are relatively small units here, but the bigger units tend to handle things like full pallets. Also non-conveyable. So typically distribution centers or parcel handling companies will handle non-conveyables through tuggers. They'll put them into carts, and we're seeing mobile robotics being applied in that space as well for handling those non-con type products. Okay, so another poll question for you all. I'm going to put down your email and get into the poll question. So where do you all see the biggest value for robots in the warehouse? So I covered a few examples here. Receiving dock, so truck unloading, palletizing, or shipping dock for truck loading, order picking for items and cases, the unit load handling, storage and retrieval, or sortation. There's been some interesting things that have been happening in the sortation front. So we talk about like the receiving dock. Like I said, you know, when you're unloading those containers, you're going through and applying that robotic technology to pull those products off of the containers or trucks, and the palletizing is for, you know, palletizing that product so that you can put it off into your storage and retrieval. That's more of the receiving area. Shipping is primarily around the truck loading applications. So I'll go back to that. I'm going to keep on going here, and then I'll get your feedback here in a minute. So making robots a reality in your DC. So I put down some thoughts here about how some lessons learned and some things to think about when you're applying robotic technology if you've not used robots before. So what are these considerations? Recognize that a lot of the data that you need to deploy these solutions, it doesn't exist, and it will need to be collected and understood. So as much information we have today in a distribution center or a retail environment, it's geared towards that manual operation of manipulating objects, manipulating cases. And so a lot of detail about what the robot solutions need to be able to handle those items, it really doesn't exist today. We have things like cubes out of cases, and we might have some folks may have some weights of cases, but that data changes very, very dynamically. And so really understanding what those are, it's critical for a robotic solution to really understand the bounds to what you can apply these robotic solutions. So recognize that you might have SKU lists, you might have details with the products that you have, but there's a whole set of information that will need to be collected before you really go through and deploy some of these robotic solutions. Certainly not saying all of them, but certainly some of them, you're going to need to make sure that you really understand the application data. Pilot programs. They're really critical to understanding the variability and determining whether the true value in ROI is. This robotic technology isn't necessarily like a conveyor system or something that is a known, I know my conveyor is going to move from point A to point B, and I know what rates and what speeds that those things run at. With these robotic solutions, there is this variability that changes throughout the year that can have an impact to the robotic operation. And so establishing pilot programs, understanding the real value that the robotic solutions bring to the end user and being able to deliver it is a very important piece here. Number 3 is really limit the scope of the projects to be as structured as possible. As much as we want to have Rosie the robot out there doing this work, she just doesn't exist yet. And so when we think about viable solutions and viable opportunities for robotic solutions, especially if this is the first endeavor down the road here, don't shoot for the moon, because right now we don't have a rocket that'll get us to the moon. But we can do a lot. And so if we can constrain the problems and the solutions to a subset of, instead of an infinite amount of variables, reduce the number of variables, and you're more likely to be successful at this. Whether that's limit the number of SKUs that you're having for a robotic each picking solution, or limit the weights of the robotic solution that you're doing for palletizing. It's constrain those variables within reason so that you can apply this technology and have some degree of success. And number 4, understand what these solutions can and cannot do. It is so easy to overestimate the capabilities of robotic solutions. So thanks, YouTube, for that. I mean, we all have gone out there and seen some awesome robotic videos. I certainly have, and I can't tell you how often people come up, hey, look at this. This is some really cool robotic tech that was shot once in an extremely constrained environment. And so people will overgeneralize what the capabilities are of the robotic solutions. That's not to say there's some really cool stuff going on there. But just have some realistic expectations about what these solutions can and can't do. And when you're evaluating those, make sure that you as an end user, make a good assessment of the capabilities of where that technology is at. So the polling question before I move on here is, so the polling question results are up. 38% are on the order picking, the case and item level. 23 are at the unit load handling. We've got 11% on the receiving dock, 9% on the shipping wing, and 15% in sortation. 2% in others. It'll be interesting to find out what those are. All right, so another factor to consider here is when you're selecting a robotic integrator. The robotic integrator is critical to the success or failure of those robotic applications. I'll start with my last bullet point here. Is remember that you're buying a system, not just a robot. The robotic technology is cool, and you can do some interesting things with it, but it needs to work within an overall ecosystem as a system to really provide that end value. So a lot of these solutions will have not only just the robotic piece, but then all of these accoutrements around it, whether it's conveyance, sortation, other software solutions for routing and item handling, that all need to work in concert together to provide you the value you're looking for. So the robotic integrator really needs to have an extensive knowledge of the industry, of the automation industry, to be able to pull in not only just the robotic technology, but all these other pieces and parts. Needs to have a deep understanding of robotics across the organization. Really, how does the robot apply? Where does it work? Where doesn't it work? And can be a partner with you on how this technology can best be deployed and where it can be successful. A lot of this too is planning and execution. You know, make sure you understand what you're going to get, what it's going to take, what does a pilot program look like, what's the definition of success. Make sure that they've got good project management skills. Even though a lot of this stuff is newer technology, a lot of the same principles apply for executing a good project. Reputation. What kind of references do they have? Have they done robotic solutions before? I've seen where you've got some folks that, you know, have some really cool tech but can miss the mark because they just don't have necessarily all of the breadth of experience in the environment to be able to be successful. RIA certification. So RIA has a great program for robotic integrators. It's just not a rubber stamp here. RIA has a very strict program for qualifying their robotic integrators. They're tested and qualified under a whole list of criteria. They make sure that they are doing the things that are things like safety risk assessments. They have the qualified technicians. They have all the processes and procedures in place to be able to be successful and certified within the RIA. It's a great program, and I recommend you check that out. Size matters too. The larger companies, generally speaking, can execute multiple different projects, and so the breadth of the organization. If you're looking to scale these solutions, you really need to have an organization that can support that large-scale expansion, and that does come with financial security. So my last bullet point, I'll go back to that. Remember, it's not just the robot. You're buying a system, and that system is what provides the value to you all. So with that, we can get to questions.
All right, thank you, Matt. That was a really great presentation. We appreciate your time to do that. And as Matt mentioned, we're going to move on to the Q&A portion of our live event. And as a reminder, you can ask an online question at any time. In the Q&A feature along the right-hand side of your screen, simply type your question into the text area and hit send. Just please be sure to keep the send to default set as all panelists. So we have several questions that have come in. The one that I want to address is that, and this is actually just a sort of a logistics type thing, when we send out the link to the on-demand version of the webinar, you will also have access to Matt's presentation that you will be able to download from our website. So we did get a couple questions about that. So again, both of those things will be available in a few days, and you'll get an email directing you how to do that. So Matt, I'm going to move on to some questions. We have just about 10 minutes here and quite a few to get through. So well, let's just go ahead and start then, Tracy. Goodness, okay. Okay, are robots designed with an easy-to-use user interface to streamline things like operator intervention and maintenance?
Yeah, generally speaking, that's a critical component to this. So it varies from robot to robot to robot, and the level of maturity from robot to robot to robot. So I would say some have some fantastic operator interfaces. Some actually don't even need a whole lot of operator interface. In theory, that's kind of the goal for the most part. Some applications, that is. So I'd say it really depends on the application and the particular iteration of that robotic solution.
All right. Next question is, with the price coming down and the technology becoming increasingly capable, what do you see are the main challenges to widespread robotics adoption now?
I think there's a general knowledge from the end user community of what the solutions and the value that they can actually provide. Like I mentioned before, it's one thing to know that your conveyor system can do X, Y, Z because we've been doing conveyor for quite some time and we have a lot of confidence in that. One of the barriers is just general understanding of the value that these robotic solutions can provide to the end user, and getting that demonstrated to actually show the end users, hey, this is real and this can give me the value that I'm looking to achieve. So why those pilot programs are very important is getting in front, getting out there, showing that it's not just hype here. These are real viable technologies here that can add real value to your organization.
All right. So with robotic solutions, how does the output of the robot compare to human capabilities? For example, are they one-to-one equivalents, or is there a sort of a formula to know how much work I'm going to have the robot do in lieu of humans? Yeah,
and this is very dependent upon the individual solution. I would say in general, they're right around a one-to-one for human to robot. I think there are some applications where actually in some instances, more constrained, a robot can outperform. There's other instances where robots can't quite perform at the level. And it depends a lot on those variables. So the variables of the product mixes that they're handling, the shapes, the weights, the sizes, and how unconstrained that they are. And so, but in general, those are the things that are looked at as from an applications and a pilot program, is identify what are all those rates and features and functionality that you would like to see out of a robot, and then qualify them during a pilot program. Okay.
I'm going to sort of group a few questions together here with regards to the robotic unloader. So let's see, there's a question about what rate can the unloader achieve and what amount of labor savings does this translate to? And I know in one of the poll questions, I think that labor was the highest percentage of respondents. What was it, something 51%? We're
Yep.
looking, that was a concern for them.
Well, I won't dive necessarily into any specific particular machine, but I can speak generally in the industry is the robotic unloading, they're looking to be around the same rates as what individuals can do. And that varies from different customers and different scenarios. So if you're handling, heavy liquids, that your rates are going to be lower. If you're handling boxes of feathers, your rates are going to be higher. So it's really a variable from application to application to application, and even trailer to trailer to trailer.
Okay.
Second, Tracy, let me add one other thing to that.
Sure.
But I think in general, though, to be viable for a robotic unloading solution, it needs to be comparable to what individuals can do and handle, both from a range of the types of products and the rate at which the individuals can unload.
All right. What challenges have you seen connecting robotic solutions with existing automation you know, and maybe do you have some experiences that you can draw from to sort of overcome some of these challenges?
Yeah, you know, deploying a robotic solution in facilities the challenges are really no different than some of the challenges we face when we're retrofitting a legacy facility in a brownfield site. You know, a lot of the same cast of characters apply about, you know, how much footprint do these take, how do you integrate with upstream and downstream systems, what are the software integration requirements. A lot of the same kinds of challenges apply. It's just instead of tying in a conveyance and sortation system, you're tying in a robotic solution. But a lot of the same principles still apply.
All right. Are robots key to mixed load palletizing, or are there other factors? And if so, what would those factors be?
Yeah, so there's probably a whole presentation on mixed load palletizing, but so mixed load palletizing is a particularly challenging problem. Simply because, again, it's like I sound like a broken record, but because of the variability with the product types, it presents a very difficult challenge to having a robot solve the problem. So historically, the way mixed load palletizing has been successful has been a substantial amount of automated equipment, and that would require other types of robotic solutions, other things like storage retrieval solutions, to be able to sequence the whole process, to be able to build out those mixed loads with a lot of prior knowledge about what you're trying to build. And so robots are a critical component to that, whether it's the depalletizing, whether it's the storage retrieval, or whether it's the actual robot that's putting the individual cases onto the mixed load pallet. The challenge really here is ROI, as well as just the variability in the products that you're looking to palletize.
All right. Let's see here. What are some robotic advances in other industries that are relevant to distribution centers?
Oh, well, I mean, I think that there is, I think probably the biggest thing is, and how it relates to the distribution center, is just the volume. So when we think about commercial, like the Consumer Electronics Show is coming up here in the beginning of January, and there's a lot of things about robots within the consumer market. What that consumer market is doing is driving up volumes. And with that, the driving up of the volumes, the price comes down for the industrial and the warehousing and distribution market. So by having more robots out there, having more volume in the industry, the price points become more and more viable in the warehousing space. So it's not like the consumer market is actually being innovative as it relates to the actual sensors that are going out there. That generally comes more from either the startup world or the academic world. Where really the cost factors here is one of the what is really enabling this in the warehouse.
Okay, is cybersecurity a visible concern for DCs that are implementing robotic systems?
I'd say cybersecurity is a concern if you're implementing any connected solution. So it's not unique to the robotic solution. So I gave the example of connectivity for the robotic solution, but that applies to anything that is coming online within a distribution center. So it's not any more of a concern or any less of a concern. It's just, it is a concern that is paramount to any solution that you deploy in your facilities.
All right, thank you. I'm actually just looking at the time, and I think we're really at time for all the questions that we can answer today during the live event. I know that several of you did ask questions, and thank you to everyone for their participation. If we were unable to answer your question during today's live event, we will be certain to send you a response via email, and we'll try to get those out here in the next few days. Also, as a reminder, within approximately 48 hours after this live event, you can access this presentation on demand at intelligrated.com/on-the-move, and you will also receive an email, as I mentioned, in a few days with a link to the recorded event, as well as a link to a recent blog post by Matt Wicks The time is now why DCs are primed for big robotics growth. This is the first in a multi-part series, and this blog is going to focus on factors that drive demand in distribution centers for more automation, examples such as labor challenges and e-commerce growth, and how robotics have evolved to offer greater capabilities. So on behalf of Honeywell Intelligrated, thank you for attending today's On the Move webinar, and thank you to Matt Wicks for presenting. We'd like to wish everyone a happy and healthy holiday season, and we'll be sharing information soon about our 2019 webinar series. And as always, we hope you will be able to join us in the new year. Have a great day.